This video is going to be on solving and graphing compound inequalities. So compound inequalities are going to involve multiple pieces, not just one simple inequality. When you have these two pieces, they're going to be separated by one of two words. The first one is the word and that is going to be representing an intersection graph. When you have intersection graphs, you are looking for where the two graphs are overlapping. You want to know, what do they both have in common? If it's part of the graph number 1 and graph number 2, then it's part of the graph solution. So both numbers, or the number has to be in both graphs in order for it to be a part of the solution. Your other word is or. An or is representing the union. And to graph the solution set of or graphs, you are going to combine all numbers. So if it's part of one, it's part of the solution. If it's part of the second one, it's part of the solution. So you're going to take every number possible and combine it together. So let's go ahead and do an example. Our first one, we've got x is greater than or equal to a negative 2. So we're going to have two simple inequalities and we're going to combine them together. We have negative 2 and we have a positive 1. So I have my 0. We've got negative 2 over here. We've got a positive 1 over there. Our first inequality, greater than or equal to, indicates a closed circle going to the right. And then on the second level, we're going to graph our other mini inequality. X is less than 1. So above the 1, we put an open circle. Less than indicates that our arrow is going to go to the left. So let's look at our structure here for a second before we get to our solution set. Notice that my circle is directly above the number indicated. It is very important that your graphs are lined up correctly so I know where it's going to, what number it's indicating. And the first one's on one level. Our second inequality goes up to a second level so I can see the difference between the two. Now we're going to look for the solution set. In order to do this, we have to look at the word. The word in between our mini inequalities is the word and. So we're looking for the intersection or where our two graphs are going to overlap. This is the overlapping section. So for our solution, remember it has to be part of both graphs in order for it to be part of the solution. Negative 2 is part of the first one and negative 2 is part of the second one. Therefore, negative 2 is part of the solution. Nothing to the left is part of the first one, so nothing to the left can be part of my solution. When I go over to the right, 1 is part of my first one. 1 is not part of my second one because it's an open circle. So it's going to be all numbers in between a negative 2 and a positive 1. It includes the negative 2 because negative 2 is part of both. It does not include 1 because 1 is not part of both. So here is my solution. And this, sometimes and graphs are called ranges and can be written in a special way. So my numbers are ranging from a negative 2 to a positive 1. So we can go ahead and rewrite this. Negative 2, since it's a closed circle, is going to be less than or equal to x, which is going to be less than 1. I can go ahead and squish those two pieces together and write them as a special range. Notice that this inequality shows up right here, but because my smallest number came first and my x came second, I had to flip those two pieces, which means I also had to flip the greater than or equal to become a less than or equal to. So I didn't change anything there, I just squished them together, and by doing that I had to move the position of the x, which means I had to move my inequality sign. All right, let's go ahead and look at our or. We've got negative 1 and a positive 2. Our first inequality is less than negative 1, so that's an open circle there going to the left. That's our first level. Our second level, greater than or equal to 2. So it's a closed circle to the right. And because our word is or, that's the union. I'm uniting all of my pieces. I'm combining all numbers. So if it's part of set 1 or it's part of set 2, I'm going to put all of those together into 1/3 level, which is going to be my solution set. So in this case, all I had to do was recopy my pieces, and that gave me my solution. So let's go ahead and practice this some more. Look at different circumstances. I've got x is greater than or equal to 5, and x is less than -2. So we've got a -2 and a +5. Our first one, greater than or equal to 5, less than -2. At this point, your mini inequality shouldn't be an issue. You should have those simple inequalities down. It's a matter of what do you do with the pieces. Where is your solution going to be? So I look at the fact that I have an and graph this time. And remember, the and graph is where do they overlap? Well, these two lines, they don't overlap anywhere. They don't have anything in common. Since they don't have anything in common, this is going to be a no solution graph. There are no numbers that they share. All right, next one, we've got less than or equal to 5, greater than -2. So we start by setting up our graphs. First one, less than or equal to 5, closed circle going to the left. Greater than -2, open circle going to the right. And this time, our keyword is going to be or. We're going to combine every number from both sets. So this set is everything less than 5. So it's including all of my numbers going infinitely small. This one's at -2, forever continuing to the right. Now, -2, is that part of my solution? Remember, it only has to be part of one of them. So since -2 is part of the first one, it is part of the solution. So between both of these lines, I'm including every single number possible. All numbers that are small, all numbers that are big, which means it's going to be a straight line continuing forever in both directions, which is actually going to be representing all real numbers. All right, our next one. We've got our -2 and our 5, less than or equal to 5, going to the left, greater than -2, going to the right. Notice how we started with the exact same inequalities that we did in this one. There is a difference though. Instead of an or, we have an and problem. So instead of combining those numbers together, oops, what happened? We are going to look for what numbers do they both have? Where do they overlap? So my graphs are going to overlap right there. They have to be part of both graphs to be part of the solution. So -2 is part of the first one. It's not part of the second one. Therefore, it's not part of the solution. But they do share every number in between. And then we get to 5. 5 is part of the first one, and 5 is part of the second one. So 5 is part of our solution set. And that is your special range graph. Remember, our number is going to be anywhere between a -2 and a +5. All right, let's go ahead and look at a couple more, and then we'll start solving. All right, so we've got a -2 and 5. Make sure that you have them in the correct position compared to 0. So less than or equal to 5. Close circle going to the left. And less than -2. Open circle going to the left. Remember, the inequalities don't matter, well, they matter, but the solution is determined by your keyword and or. You can have the same two many inequalities like we saw in the last two problems, but the keyword is what's going to determine the solution set. And tells me that I'm looking for the overlap. What numbers do both sets have? So they overlap starting here, and they both forever continue to the left. Now, do they both have -2? No, the first one does, the second one does not. So that's an open circle going to the left. Next one. We've got the same two numbers there, -2 and 5, less than or equal to 5, close circle to the left, less than -2, open circle to the left. Notice exact same situation that we just started with, but this time we've got an or. So we want to include every possible number that was included in the first one or included in the second one. So when I look at this, all of these numbers have been included within this first one. So the numbers that I have combined together from all sets is the big line. So when you have these that are going in the same direction, if it's an and, if you're looking for the intersection, it's just the smaller of the two pieces. If it's an or, when you're combining, you're picking the bigger of the two lines. All right, one more graph and then we're going to go ahead and start solving. We've got -2 and 5. We've got less than or equal to -2, so close going to the left. Open at 5, greater than going to the right. Our keyword here is or, so we're combining all numbers. So we're combining all the numbers from the first set and all the numbers from the second set. So this one, like in our first set of examples, is going to just require us to recopy our pieces. When I combine those two pieces together in a third level, that's my solution set. Okay, so let's go ahead and start solving. When you are graphing, don't forget that you should always have 3 levels unless it's a range inequality. If we give you a range inequality, you can go ahead and just go to the solution set. Otherwise, you should have the first mini inequality, the second one, and then your solution. This first example here is solving a range graph. It's just like solving an equation, however, we do have a left, a middle, and a right. In an equation or a simple inequality, you just have a left and a right. Whatever you do to one side, you have to do to the other. So in this case, whatever you do to one piece, you have to do to all 3 pieces. My goal is still to isolate my variable. So the first thing I'm going to do is I'm going to move my 8 from the middle, but I have to move it left and I have to move it right. Remember, I have to move it to all 3 pieces. -2 and 8 gives me a +6. And 10 and 8 is going to give us 18. We divide by 3 to isolate our x. 2 is less than or equal to x, which is less than or equal to 6. So this is kind of nice. We have our special range graph, which means we don't have to do 3 levels. We know that everything is going to be between 2 and 6. This symbol goes with a 2, which means it's a closed circle. This symbol goes with a 6, which means it's a closed circle, and it's everything in between. Now remember, you may be confused being like, well, it's a less than or equal to sign. Why isn't it going to the left? Remember, we had to change the orientation when it got put together. So this is really representing the inequality x is greater than or equal to 2, which why it's going to the right of 2 and to the left of 6. Next one, we're going to do our inequalities separately. So just like our simple inequalities with one variable, we've got 2x is less than 2. We divide by 2, and x is going to be less than 1. Bring down our keyword of or, because remember that's important. We add our 7. 4x is greater than 16. We divide by 4. So we have x is less than 1 or x is greater than 4. We go ahead and set this up. Less than 1, open circle at 1, going to the left. Greater than 4, open circle at 4, going to the right. Now our keyword of or here tells me that I'm going to combine every number from set 1 and every number from set 2, which means all I have to do is recopy those 2 first pieces on a third level, and I am done. Now that we're into compound inequalities, if you don't want to, you don't have to write your 0. Those 2 numbers that we get from our mini inequalities are the 2 numbers that are important. here come our last two problems. Number 3, we have a range graph again. You're going to see this one's going to be a little bit different. So we work on isolating our x. So we move that 13 over. Negative 18 is less than a negative x, which is less than or equal to a negative 10. Now we want a positive x, so we have to divide everything by a negative 1, which brings us to our rule that when we divide by a negative number, we have to remember to flip our sign. So this becomes a positive 18 is greater than x, which is greater than or equal to a positive 10. The only problem is our range is always from the small value to the large value, and it always has less than or equal to symbols. So when we divide it by a negative and we flip the sign, we ended up having our inequality written backwards. So we just have to rewrite it from our smallest number to our largest number. So instead it's going to be 10 is less than or equal to x, which is less than 18. So we've got 10 to 18. This indicates a closed circle at 10. This indicates an open circle at 18. And because it was a range, you only had to do your solution set. All right, last one. Let's go ahead and get those mini inequalities solved for. And we divide by 6. We go ahead and reduce our fraction. 8 over 6 is going to be 4/3. Bring down our keyword of or. We divide by negative 4. And because we divided by a negative, we've got to flip that sign to be from greater than to less than, negative 4. So make sure that you have your numbers in the correct spots. The negative number is going to be to the left of the positive number. Our first inequality, less than or equal to, closed circle, going to the left. Open circle above 4, going to the left. And our keyword here is or, so we're taking both numbers, or all numbers from both sets, and combining them into one. Every number from this set is already included in this set, so our solution set is the bigger of the two lines. All right, and that's everything that we have for compound inequalities.